Hey guys, I want to welcome everybody back to some chemistry videos. We are going to start our new unit with Introduction to Stoichiometry. Now you may have never heard the word stoichiometry before, but basically we are going to be doing some molar conversions. If I, for example, give you a starting amount of material in a chemical reaction, you should be able to, by the end of this unit, tell me how much product is produced and, in a way, how much excess of my reactants might be left over. So you'll see what that looks like here in a bit, but we're going to be doing a lot of math this unit and a lot of molar conversions. So I hope you're ready to go for this, because I am ready to rock and roll. Let's talk about some of our learning targets for this video. Hopefully by the end of this video you will be able to understand the purpose of stoichiometry and utilize the mole ratio to convert between different chemicals of a chemical reaction. Your only key vocabulary terms are two words I just used. It's stoichiometry and mole ratio. Wasn't sure if that was a laugh or it kind of sounded more like a the Count Von Count from Sesame Street. Blah! Stoichiometry and mole ratio. We have two moles. I'm going to move on. So stoichiometry is basically it's the relationship between the reactants and products. More particularly, if I start with a certain amount of materials at the beginning of my reaction, how much product can I produce from that reaction? So think about how we make sandwiches. I put a picture of a wonderful bologna sandwich on here. And for making a bologna sandwich, we really need two things. We need bread and bologna. Well, if I start off, let's say that 2 pieces of bread make up a sandwich, and 2 pieces of bologna make up a sandwich, we can do a little bit of math here to figure out how many sandwiches I can make at the end if I give you so many pieces of bread and so many pieces of bologna. So for example, if I have 10 pieces of bread and 10 pieces of bologna, then, based on my formula of 2 pieces of bread and 2 pieces of bologna per sandwich, I can make 5 sandwiches. If I have 20 pieces of bologna and 20 pieces of bread, I can make 10 sandwiches from that. So we need to think about the relationship between our reactants and our products to kind of determine what we're going to get at the end, just like our sandwich example that's just given. So how do we know the relationship here? Well, we utilize something that is known as the mole ratio, and the mole ratio is the ratio of moles in a balanced chemical equation. Essentially, these are the coefficients of your balanced chemical equation, and we can use these as a conversion factor between one mole of substance and another. And this conversion factor is very important because it is the only way that we can convert between reactants and products. We can't use grams, we have to use a mole ratio. So if we look here, between oxygen and ethylene, so we have ethylene reacting with oxygen to produce carbon dioxide and water. What this chemical equation basically says is that if I take 1 mole of ethylene and 3 moles of oxygen, I am going to produce 2 moles of carbon dioxide and 2 moles of water. Now we can convert between all of these different chemicals utilizing the mole ratio that's described on the right-hand side. Okay, so again, we're going to be doing dimensional analysis, so we need to think back to our dimensional analysis unit. So let's take a look at this practice problem to start. Carbon dioxide reacts with lithium hydroxide to form lithium carbonate and water. How many moles of lithium hydroxide are required to react with 15 moles of carbon dioxide? So there's a couple of things that are going on in these problems. You're going to need to work back to our last unit and think about how do we write balanced chemical equations, because you're going to need to do that properly in order to properly write out the answers to these problems. So the first thing I'm going to actually look at here is I'm going to look at what's given to me in the problem. So I'm given a chemical reaction here. Okay, so I'm obviously going to need to write that out and balance it. I'm also given that I start with 15 moles of carbon dioxide. Now what it looks like to me the question is asking for is how many moles of lithium hydroxide. So what's going to happen is I'm going to have to convert 15 moles of carbon dioxide to moles of lithium hydroxide. Well, our first step is going to be to write a balanced chemical equation, so let's do that first. So we have carbon dioxide, which is CO2, reacts with lithium hydroxide. We need to make sure I write our formulas correctly. Lithium has a +1 charge, hydroxide -1, so we're good there, to form lithium carbonate, And again, make sure to indicate your charges. So it's going to be Li2CO3 and water H2O. All right. So if I take a look here, we have our formula. Now let's see what needs to be balanced here. Well, carbons are 1 and 1. Oxygens 3 and 4. That's icky. Let's look at lithium. Lithium, there's 2 on the right side and 1 on the left. So let's put a 2 in front of LiOH. And let's see what that gives us. So we have 1 carbon on each side. We have 4 oxygens on each side and 2 hydrogens. So that balances our equation. Awesome. So now let's get to our actual question. How many moles of lithium hydroxide are required to react with 15 moles of CO2? So let's start with what we know. We're going to start with 15 moles of CO2. Okay? It's a dimensional analysis problem. Remember, whatever unit is on top of the first step has to go on the bottom of the next. So we're going to have moles of CO2. Okay? Now, to get it to moles of lithium hydroxide, we have to use the mole ratio. Anytime I am converting from the mole of one substance to the mole of another, I must use the mole ratio. The number in front of CO2 is a 1. Remember, anything that's not written there is implied as a 1. I want to convert to lithium hydroxide, so I'm going to convert to moles of lithium hydroxide. If I look here, moles of lithium hydroxide, there's a 2 in front of it, so I'm going to use a 2 there. All right, now I need to take a look. Are the units on top of my last step what I want? Yes. Okay, so now all I need to do is do some math. 15 times 2 divided by 1 is 30 moles of lithium hydroxide. So it seems pretty easy to start off with, but keep in mind as we continue to work through these types of problems, we're going to start utilizing and implementing grams into this. So you'll stay tuned for that here in just a little bit. But keep in mind, we need to write our balanced chemical equation first. Once we've written our balanced chemical equation, we need to look at the question and figure out what is it asking for and what do we want out of that. We start with what we know and utilize the mole ratio to convert from one chemical to another. Remember, this is the only way that I can change chemicals. Okay, I went from carbon dioxide to lithium hydroxide. There is no other way that you can go from one chemical to another. Okay, so make sure you understand that utilizing the mole ratio is the only way we can convert between different chemicals. So I only went through and did one practice problem here, but I think it's pretty straightforward. You just simply utilize the mole ratio that's given from the balanced chemical equation to convert from moles of one substance to another. Keep in mind that stoichiometry is the relationship between the reactants and the products of a substance, and that the mole ratio is used as a conversion factor between any chemical substance in a chemical reaction. And just so you guys know, I'm going to make sure we're all paying attention here and watching through it. The secret code for the video this time is going to be products. Okay, so you need to write this down where it says the secret code. The secret code here is products. So make sure you are aware of that when you submit your form. And again, hopefully you understood the learning targets today. We're going to continue our work with stoichiometry moving forward. Hopefully you got a lot out of this video. I know I did. I look forward to talking to you guys a little bit later, and we will see you soon. Have a great day, guys. We will talk to you later. Bye-bye.